So we're going to do the article review that you all read. The general assessment was the product was a better product than what we saw last week. The thing that I'm going to focus on here, and your comments were well stated, we have tables and so forth. I want to get to the results section and talk a little bit about the results section. I'll ask that you just write up a little bit about this, a couple of sentences, because I want to teach you a little something about this. There was a comment, I think, made by one of you that you didn't realize it was a two-factor ANOVA. So I want to talk about the design and the data here. That's going to be the focus of just this one part, and that's going to be it for this article. How can you tell from this table that it was a two-factor ANOVA? Do you guys know what the two factors were here?
Diabetes and ethanol.
Yeah, the two factors here. Now, they were not manipulated. But the two factors here, they call it diabetes prevalence. So you might call it group or diabetes prevalence, and there were how many levels? Two levels. You either had diabetes or you didn't. So one variable for your notes is diabetes prevalence. I might have called it group or condition, but they called it diabetes prevalence. We had no diabetes and diabetes. What was the second? Kind of
Ethanol consumption,
yeah, it was ethanol consumption. And how many levels for that? Three. None. Moderate and heavy. Apparently we don't have too many light drinkers. This study was not done on Hawaii. No. Actually, no, it may have been done. Never mind. Japan. Yeah, kind of interesting. So we have that. How about dependent variables? Was there just one DV? They actually had quite a few. If you look at this table, there were actually 3 different DVs, so they would have had to do they would have had to do 3 two-factor ANOVAs. You could actually do another statistic on all of them together and really confuse the hell out of everyone. The name of that statistic, if you look at all 3 DVs at once, and you don't have to write this down unless you care, it's called a MANOVA. Only men can do it, though. It is called a MANOVA, though. Multiple analysis of variance. That's a standard. So it's a 2x3 design. Now, they tell you here, if you look down here, it's interesting. If you do a two-way ANOVA, what are the 3 effects we can always look for in any two-factor ANOVA?
Main effect of A, main effect of B, and an interaction.
So you can always look at that, and they actually tell you here, okay, diabetes prevalence, that's going to be, is there a main effect? You might be able to figure that out, diabetes prevalence. Is there a main effect of ethanol consumption? And then you can kind of tell it's a giveaway down here on the 3rd line. Is there an interaction? So they do that, and they tell you things, and they have statements. But is this easy to figure all this out? No, why not? You can't really see it too well. So what I decided to do, for the sake of the class, and what they should have done here, pull this up, is I actually decided to make my own little table here. If you ever get a situation like this, it's good to make up a table. And if you can't, ooh, yellow highlighter pen. Is that working out well for you or what? Oh, okay.
That's what I wrote that out, but
What I actually wrote down here, and if you wouldn't mind just doing it in this particular example, look what I did. ALK, then abstinent, moderate, and high. A group, or what they call prevalence, no diabetes and diabetes. What do these numbers represent? The 6 numbers in the table represent, for me it was, what is the name of this variable? The first column, the first DV. THEY or something? THCY? So I made a table of this. So do you see where I put the 9.1? Can you see it on the table? And then I put the 9.55, I made that a 9.6. I put the 9.36, made it a 9.4. And then I took the other 3 values, 8.9, 9.0, and 10.25. I rounded here. Can you guys see where I got that?
Um,
Or not quite?
not quite in front
Sure. It's these values. The first column, the 9.12, 9. I just put them in their columns.
of you.
I just made this table for the 1 dV here. Because if it's in a table like this, from,
That's way easier.
say again?
That's way easier.
It's a lot easier because if you have 6 values here, what can you then do with this? If you have a 2 by 2 or a 2 by 3, what were the 3 effects we could look for?
The main effect of each factor and
The interaction. So let's start. If you look at this data, does it look like there's a main effect of prevalence? And how would you figure that out? Just eyeballing, because it's hard to eyeball that. But if you were to take this, is there a main effect of prevalence? What would you do in our matrix here? What are the 2 levels of prevalence?
non-diabetic.
None and diabetes. And what would you do? With non-diabetic, you would go right across and get a marginal mean here, a 9.33. And what would you do if it was diabetes? Do the same thing. And I just approximated, how do these 2 numbers look? A 9.33 versus a 9.4. Pretty close. Do you think there'll be a significant main effect of prevalence? The numbers are about the same? No, there should not be. And if you go down here, what does it say? So for someone like me, if I really wanted to understand this, I'd make a table. I could understand their words. So it looks like there's no main effect of group here. What's the second main effect you could look for? Alcohol. Now it's a little different here because we don't have 2 levels, we have 3. But what would you do? You'd get a mean for abstinence. The mean is 9. Moderate, 9.3, and high, 9.85. Do you think these 3 numbers are significantly different? Well, if you look at the printout, it actually says what? It says 0.01, so this result is significant. So it looks like if you're on the high amount, you've got more of this in your system. And what's the third and final thing we can look at? The interaction. What you would want to do, and I'll give it my best lousy shot here, is you would make one line for here. So 9.1 to 9.6 to 9.4. I'm just going to go 9.1 up 0.5 to 9.6 down to 9.4. So that's one line. What does the other line do? 8.9 to 9 to 10.3. Are those lines parallel or non-parallel? They're very non-parallel, so there's probably what there? An interaction. What does it look like is going on here? Which cell is looking particularly bad? Yeah, if you're a diabetic and you take a lot of alcohol, that's a bad idea. As if we didn't know that to begin with. But so I think that's all I really want to cover for this. I think last year when I covered it, I said, do the same thing for the folate and vitamin B. But this is just more, if you ever get something like this and it's complicated, see if you can make a table out of it to give it more sense, because it's really hard to interpret these things. It looks like with folate, when you're drinking alcohol, it looks like if you're a diabetic, it's worse. There's just a main effect there, and it looks like the more you drink, the worse. No significant interaction. And the same with vitamin B. The more you drink, the worse that is for vitamin B, and the more you have diabetes, the worse that is as well. So this was an example for your take-home message. This was an example of a design that was a 2 independent variables or 2 variables. It was a 2 by 3 design. They actually had a number of dependent variables. And what I'm recommending for something like this is, if you ever get something like this in the future, try to make your own little chart so you can kind of see what the heck is going on. It's very hard to figure all this out. Their statements are all right, and their conclusions are all right.
Do you want this in
In the notes, yeah, just have a paragraph on this. I will allocate, because it seems like we're covering a lot tonight. I will, I think I had 50 points of the class notes. Maybe I'll make it more like 75 or something, because it seems like there's a lot of notes for tonight. So we had that. Was there anything else? No, I think that's